Welcome to the video lesson, Development of a Mini Collection of Knits. This session is entitled Context for Knitted Fabric Design. When and where hand knitting began is unknown. First written references appear in the inventories of religious houses in the Western Europe in the 12th century. They refer to very basic domestic items such as knitted leggings and gloves. By the late 1500s, the craft of hand knitting had developed into a sophisticated industry, carried out by men and controlled by national guilds. The first knitting machine was invented by the Reverend William Lee in 1589. Further developments over the following 200 years involved enhancing the facility and efficiency of the knitting machine, allowing a variety of pattern and texture fabrics such as intarsia, jacquard, stitch transfers, and pointelle. This, in turn, led to the development of a wider range of knitted structures and products such as knitted lace, underwear, sportswear, and eventually to knitted outer garments or knitwear as we know it. The next slides provide some dated milestones in the evolution of the knitting industry. Essentially, there are four main processes used in knitted fabric manufacture, which are: number 1, circular knitting; number 2, fully fashioned; number 3, flatbed; number 4, complete garment. Circular knitting. This process produces a continuous tube of weft knitted fabric that can be used as a tube if the diameter is appropriate, or as a fabric for t-shirts, underwear, sweatshirts, or fleece. It provides the fastest and most cost-effective production method for knitted fabrics, and essentially simple structures can be achieved. Fully fashioned. This manufacturing process is mainly associated with high-quality knitwear made with luxury raw materials. The technology involves the manufacture of shaped body panels of single bed fabric that are then assembled into finished garments, thus minimizing waste. Wool garment. The first seamless garment production machine was introduced in 1995 by Shimasaki. This technology offers the design and versatility and innovative potential, as advanced three-dimensional garment shaping can be combined with texture and color use. Flatbed knitting. The early forms of this weft knitted fabric technology already offered the design and most versatility and choice in terms of color, texture, and patterning. To provide the context for the upcoming contents, we are now going to provide some basic knitted fundamentals. Knitted structures are progressively built up from row after row of intermeshed loops. A cohesive knitted loop structure is produced by a combination of the intermeshed needle loops and yarn that passes from needle loop to needle loop. Each knitted loop is an upright nose which has a head, 2 side legs, and 2 feet. Where the lower part of the loop joins its neighbor, the single loop is formed. A course is an horizontal row of needle loops produced by adjacent needles during the same knitting cycle, whereas a wale is a vertical column of intermeshed needle loops, generally produced by the same needle knitting. For knitting a fabric, only one set of yarns is to be supplied to the knitting machine. Depending upon the direction of yarn movement during loop formation, with relation to the direction of fabric formation, knitting technique is classified as warp knitting or weft knitting. If the yarn runs in the width or crosswise direction with reference to the direction of fabric formation during knitting, then the process of knitting is called weft knitting. In case the yarn runs in the length direction, the direction of fabric formation during knitting, the process is called warp knitting. Weft knitting machines are classified in various ways. The main basis of classification is the needle bed. By needle bed, we understand the platform or frame on which needles are arranged at a regular pattern. The number of needle bed in a machine may be 1 or 2, and accordingly the machines are called either single bed or double bed. According to the shape of the bed, knitting machine may be either flat bed machine or circular bed machine. A brief classification of weft knitting machine is displayed in the slide. Based on the features of warp knitting, the machines available are classified into two categories, tricot and racial. Both tricot and racial may be made with either a single needle bar or a double needle bar. In a warp knitting machine, there will be a simultaneous yard feeding and lap forming action. A brief classification of warp knitting machine is given in the slide. Machine pitch or needle pitch is defined as the distance between the centers of two neighboring needles in one needle set measure on the nominal machine diameter or width. Definition of gauge depends on the types of knitting machine. Most popularly, it is defined in the English system as the number of needles per inch. Weft knitted structural units can be represented using the following methods. Number 1, line diagram. Number 2, symbolic notation on graph paper. And number 3, schematic or diagrammatic notation. Line diagram representation is easily understood by the beginner, but it is comparatively difficult to produce, particularly for complex designs. Symbolic notation on graph paper is widely used for the representation of knitted structures. Any type of loop or knitted structure can be represented on graph paper with the help of some symbol. There are a large number of horizontal and vertical lines at equal distance which divide the paper into a large number of squares. Each square is used to represent one loop. The horizontal rows are used as courses, whereas the vertical columns are used to indicate the wales in the knitted structure. The presence or absence of some particular symbol in a square indicates the various types of loops or stitches. A cross mark inside a square represents a face loop. A blank circle inside a square represents a back loop. A dot inside a square represents a tuck loop. A blank square represents float or miss loop. In addition to graphical representation, the knitted structure can be shown with the help of schematic diagram on point paper. The schematic diagram describes the movement of the yarn across the cross-section of the needle during the loop formation. A tuck stitch is formed when a needle already holding a loop receives a further loop. The held stitch is formed when a knitted loop remains on the needle whilst others in the same course are knitted. Combining a held loop with a knitted loop produces a float or a miss stitch. The four primary structures, plain, rib, interlock, and purl, are the base structures from which all weft knitted fabrics and garments are derived. Each is composed of a different combination of face and reverse matched stitches, knitted on a particular arrangement of needle beds. Each primary structure may exist alone in a modified form with stitches other than normal cleared loops, or in combination with another primary structure in a garment length sequence. Possible effects on knits based upon color, structure, and a combination of these two are demonstrated in the following slides. The potentialities of a CAD/CAM system for the knitting industry can be described as follows. Number 1. Capacity to create and edit a construction of model including all its parts of the products. Number 2. Able to support a set of standard constructions of knitting models. Number 3. Able to create a knitting model including all sizes variation. Number 4. Able to create different types of knitting structures according to machine capabilities. Number 5. Able to manufacture different knitting techniques, such as jacquards, intarsia, cables, lace, iron, and so on. Number 6. Automatic generation of knitting control programs to implement the models. Generally speaking, A pattern of knitting structure can be drawn as a raster graphic image, where the smallest item of the grid corresponds to a knitting stitch. The discrete nature of knitting patterns, which are matrices of smallish numbers of stitches, makes it relatively easy to represent formally stitched structures. To describe a knitting pattern structure, the grid's items are filled with different colors or icons. Universal and Shimasaki use color coding, whereas Stow use symbols to represent individual stitches as part of a language derived from BASIC, and has introduced an iconic representation of predefined stitched structures. And that concludes our lesson. I'm hoping that you enjoyed. Thank you so much for your time and attention.